Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Paul Mackin. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Just as a reminder, York Universe broadcasts live every Monday night, almost, except for holidays, at 9 p.m. local Toronto time, or of course Tuesday morning at 2 a.m. UT, if that's more your speed. We can be found live on YouTube at York U Observatory in concert with our online public viewing program run by the amazing observatory team. And of course, after the live broadcast, we do appear as a podcast, as I say, wherever podcasts are distributed. So that does include, of course, Spotify and Apple and all the rest. To navigate to the live show or find out more, check out our website, yorku.ca/science/observatory, and follow the links to OPV for online public viewing. You can also click any of the links on our website that say YouTube, and they'll take you straight to the live show. If you have any questions or comments about past shows or suggestions for future topics, you can always email us at observe@yorku.ca. And of course, you can find us on Instagram or PixelFed at Instagram at York U Observatory and Facebook or PixelFed at LNI Carswell Obs. And all of our programs are free, but we do have a very special donation site up on our website right now. So if you'd like to help out the observatory and find out what we use your donations for, you can see that same website, yorku.ca/science/observatory. Our crew is monitoring the chat room live over on YouTube, looking for questions and posting content. Now, as always, if the weather is clear, we will open up the 1 meter telescope, but if it's very cloudy, you'll see beautiful archival images, and unfortunately tonight does indeed look very, very cloudy above the observatory. So we'll go ahead and see, Paul, how's the weather where you are tonight?
Well, it's snowing quite heavily, actually, and tomorrow is going to be a bit of a dig out because I think it's snowing overnight. And of course, this is February, which is always the time I get a cold. So I'll apologize. My voice is a bit hoarse tonight, but yeah, it's February. It's Canada. Yeah, what you
Yeah.
expect.
Yeah, I was watching the snow come down on the all-sky camera above the telescope earlier, and I thought, gosh, it does not look like we're going to open up tonight. But we can always hope for more clear nights later on down the road, maybe later on in February, or in more, better yet, in March when Saturn's rings disappear.
Yeah,
Alrighty.
that's an exciting time, and it doesn't happen all that often. And I was looking at it just the other night, and it's getting narrow and narrow. There's very little ring left, but come March, they go away for it's probably about a month on either side. So we're getting to the point now where you just can't see them.
Yeah, it is getting more and more difficult, and that's something that we were calling out last week as well. Folks, if you have clear skies and even just a pair of binoculars, go on and have a look uppity. If you do happen to have a telescope, you will be able to see the rings getting thinner and thinner and thinner and thinner, and they will be nearly impossible to see going forward up until the point where they're really, really impossible to see because even with more advanced telescopes, you just can't make them out because they are too thin, and when they're pointed directly at you at just the right angle, it's just too thin to see. But it's a great opportunity to break out our viewing assistants and, of course, telescopes if we have them. So I think we will go ahead and just advertise that the Allan Carswell Observatory will be using our fancy 1 meter telescope whenever the skies are clear to try to get as many pictures of Saturn as we can during this sort of fun time of year, because we're not going to have this happen again for quite some time. And as always, like to say, this is a lot easier than actually traveling to Saturn ourselves or even sending a spacecraft there, because even with our ground-based observatories, we can do a lot of wonderful monitoring. And what I always like to say is, of course, telescopes do make the best spaceships because how else could you possibly manage to go from star to planet to asteroid actually faster than the speed of light? I haven't found any other methods, so it's still my favorite.
And that brings us to our theme for tonight, which of course is that telescopes, telescopes, telescopes.
Yes, and there are so many wonderful telescopes. I don't think we are even going to be nearly able to cover them all. But I see that you've got us started off with This Week in Space and Astronomy History with a really, really fun one. So why don't you take it away, Paul?
Great, thanks, Dr. Hyde. So it isn't quite this week in history, but it was last week in astronomy history. On January 26, 1949, the Hale 5.1 meter or 200-inch telescope became the largest telescope in the world. Often referred to as Mount Palomar for its location, it is one of several telescopes on the site. Construction on the Hale telescope began in 1936, but World War II slows things down a bit, and construction was completed 12 years later in 1948. The commissioning began with the commission beginning at that time, and first light was 76 years ago. Now, numerous discoveries, far too many to mention here, are accredited to Hale, including quasars, active galactic nuclei, of which quasars are one type, two moons of Uranus. The telescope could image objects down to the 23rd magnitude, which is about 100,000, probably a little more, times fainter than the human eye can see. And all these years later, it's still in use as a significant research laboratory because the optics are very good and you just change the instruments. One of the nice things about telescopes. The creation of the mirror is a story in itself because they didn't really know how to do it. So Corning Glass Works in New York State was commissioned to build it. And again, they had really no idea what they were doing. The first attempt using quartz glass failed with a cracked mirror during the annealing process. And it's now on display at the company museum. I've actually been there and seen it. And 5 meters doesn't sound that big, but for one solid piece of glass, my God, it is unbelievably large. It's really impressive. They were successful with a second mirror, which used a honeycomb design at the back to reduce weight, and it used, for the first time, low expansion Pyrex, which is borosilicate glass. And they had a very careful annealing and cooling process. Once cast, the mirror took 8 months to cool. The primary mirror was shipped by rail to Pasadena, California, where it was coated and used for use at the observatory. But it was a big deal. People were lining up on the railway tracks to see this large covered mirror roll by. This was a really big story at the time. Interestingly, the Hale telescope remained the largest functional telescope in the world for nearly 30 years. But in 1976, the Soviet Union commissioned a 6.04-meter telescope called BTA 6. It's an acronym, and translated English, it's Large Azimuth Telescope 6 in Russian. However, it was beset with technical problems and to this day has proven ineffective as a major observing instrument. Around the end of 1970s, though, new approaches to telescope design were developed and leveraged multiple mirrors or mirror segments. And towards the end of the 20th century, new mirror construction techniques, supplemented with adaptive optics and advanced control systems, have resulted in mass observatories of 10 meters or more in diameter. Some observatories still under construction or in commissioning, and we'll discuss that later in this podcast, have mirrors of up to nearly 40 meters or 8 times the diameter of Hale. And just because of the way telescopes work for gathering light, 8 times the diameter is 64 times the light gathering capability.
Yeah, this is just a wonderful, wonderful telescope. I'm so glad you've included it for the first object of the evening. And of course, it's close enough to This Week in History, I think is definitely allowed. And being out at Palomar, it was also part of course, the Palomar Sky Survey, which we do have a few plates for. at our own observatory. It's still one of the most popular surveys I think ever done, and there is a wonderful sort of image just showing how telescope mirror technology has expanded, shall I say, over the years because the larger mirror you have, the larger light gathering capacity you can manage, but also the better resolution of the objects you'll be able to image. So of course they have a 5 meter mirror and it's quite a bit older. The Allan Carswell Observatory, we have a 1 meter mirror and we can also go down to magnitude 22 or 23 on a particularly clear night, but the object resolution is not going to be as good because we have a smaller mirror. And of course, the weight, I should actually say, one of the real dangers of these uh, older type of glass mirrors is the incredible weight of them. You know, with several tons, 4 to 5 tons or something or more. And the incredible weight would cause the mirrors to deform even if they didn't necessarily break. And so creating mirrors that won't deform or won't change their shape and become unusable was a real problem until material sciences kind of came up with some really fun, interesting ways to solve the problem in mirror design and, of course, mirror shape and segmented mirrors. Oh, just great stuff. But I'm also glad you mentioned Palomar because this was actually, I think, and I'm going back, I'm pretty sure this was one of the first large telescopes I ever got access to. And it's kind of a fun one, blast from the past. A long time ago in a land far away, I was driving to Arizona in an old 1983 Mazda GLC two-door that was barely working. And I was going to get into the University of Arizona, and I was like, I'm pretty close to Palomar. I'm going to drive by the Hale telescope. And I was not an astronomer. I had no credentials at this point. And I got up there and started talking to the guest house owner. And this is a great thing about observatories. Generally, people who work there tend to be very enthusiastic. And I actually managed to talk myself all the way into the operations room of the Hale telescope, and I still have that picture somewhere. They did not let me touch any buttons, but I do have a great picture of me sitting in front of some very nice old controls because the control system for this telescope has been updated a little bit, but a lot of the original controls remain, which means you have some wonderful old 1950s electronics in there and just a beautiful system. And of course, if you do ever manage to get up there, I don't know if sorry, it was gift stop or gift shop owner. I don't know if it's still her husband who works up there, but a lot of times, if you express great interest in astronomy, people will let you come and hang out near the telescopes. And of course, now with the Allan Carswell Observatory, we let people come in every single Wednesday. So wonderful story and wonderful telescope. Now, speaking of telescopes, I suppose, I've got another telescope that is very pertinent to this discussion. Now, back in 2012, I suppose, so gosh, more than 10 years ago now, February 8th, so a few days from now, we had a very special occurrence at the Keck Observatory. And this is when the Moss Fire instrument was delivered. Now, Moss Fire stands for Multi-Object Spectrometer for Infrared Exploration. And its arrival up at the Keck Observatory, and the Keck Observatory is on Hawaii on the large island, and the Keck Observatory is its own amazing telescope, but it's actually got a lot in common with the Allan I. Carswell Observatory because it's two telescopes. So they, like us, have two domes, However, their domes are not raised up on giant stilts like ours are. Their domes are very flat across the ground and very, very much larger. They have two telescopes up on Mauna Kea, which at the summit, or near the summit, I suppose I should say. There are higher points to Mauna Kea, and both of their telescopes, which are twins, have 10-meter aperture primary mirrors. So it was already a very, very impressive telescope with first light happening in 1990. And the fact that you had two telescopes right there means that you can do some really, really interesting um, types of sort of combination observing. And they had a whole bunch of types of different experiments running at various different times. And depending on what instruments are on which of the telescopes or are they in the middle, you could use the combined light from both telescopes or you could use the light from one telescope or the other. So really cool setup, really cool instrument. And then MOSFire arrives, of course, and on site. And it arrived in 2012 of February 8th. And then we started getting data. So MOSFire was an amazing, fun telescope addition, I suppose I should say, and its spectrometer for infrared exploration allowed us to go into what I like to call basically predator vision, which is where you're not viewing the visible light part of the spectrum, you're viewing more of the infrared light, which is basically what you get from hot sources. So if you've ever seen thermal imaging or heat imaging or the movie Predator, you probably have an idea what thermal radiation might look like. And infrared is in that realm of radiation, shall I say, or towards that direction for your light wavelengths. The first light didn't happen until a little bit later, of course, because it takes some time to get everything working, as we know also at the Allan Carswell Observatory with our spectrograph. Just we haven't given it a name yet, but maybe we'll call it maybe not fire, as it says that's a little dangerous. But MOSFire worked great, and it had its first light with the Keck 1 telescope. So they put it only on Keck 1, not in the middle point or on Keck 2, and that happened in April 4th of 2012. So they had a few months of hooking everything up and testing it, making sure they weren't going to break anything, and then they had multi-object spectrograph, where you could take spectra of multiple objects in your field of view with a wide field camera at this really interesting wavelength, near infrared 0.97 to 2.41 micrometers. And it had all kinds of great features. So MOSFire is led to a lot of really interesting discoveries. And because it has a wide field camera, you can see a good deal of the sky, and because it has bars that move in and out from each side, which form up to 46 short slits. And when the bars are removed, it actually can just be a wide field imager. So huge amounts of capacity and lots of fun things happening with it. It is only one of several instruments that have had great fame over at Keck, and of course produced beautiful science results as well. I will say that it is probably one of my favorites because, of course, spectra results are always really, really fun. But if you do want a little bit of fun telescope history for, I suppose, how many days is that? 5 days from now? Yes, I can still add tonight. But yes, MOSFire was first delivered to Keck Observatory on February 8th, 2012, and it has been up there making fun discoveries and spectra of multiple objects as well as wide field imaging ever since.
Yeah, the Keck story is incredible. I mean, it's I think we've had some grad students at York work there as well, get observing time on it. But
Oh
it's a
yeah,
behemoth. It's a behemoth, and probably one of the most, if not the most serious observing platform on the planet right now. It's in the top five. But yeah, and of course you've got a whole observatory row on Mauna Kea. Including Canada, which has a great telescope there, the Canada, Hawaii, France telescope, which is
it's a CFHT.
Yeah, yeah,
So
it's and I think I believe that is now undergoing refurbishment. But
yes, that's
yeah,
correct.
yeah,
And there's
but
actually a conference coming up this April for CFHT users. So if you're thinking of observing with CFHT, they're all going up to a very nice looking resort in Quebec in about, I want to say, 2 months. So another fun crossover.
yeah, that would be not a bad place to go. Uh, but speaking of revolutionary telescopes, um, February 11th, 1997. So again, I'm a bit out. I seem to be a bit out on this week for both these items. We saw the launch of Space Shuttle Discovery on STS-82, which was the second Hubble Space Telescope servicing mission. Now, the Hubble Space Telescope, with a 2.4-meter mirror, so half the size of Hale, a little less, is not a particularly large telescope in terms of light gathering capability. But because of its orbit above Earth's atmosphere, it has very high resolution. The HST, as it's known, launched in 1990, and it had a flawed primary mirror. Again, as with Hale, this was new technology, and mistakes can easily be made when you're doing something for the first time. That being said, Hubble was designed to be serviced by the space shuttle, and so 3 years later, servicing mission one was launched with the primary purpose of installing corrective objects. They put eyeglasses on the darn thing. Um, to allow Hubble to achieve some of its most of its mission goals. The mission was successful. In fact, it was extraordinarily successful, and that paved the way for just over 3 years later for servicing mission two to deploy some new science instruments and perform some maintenance on the telescope. The new instruments included the Space Telescope Imaging Spectrograph. That's Dr. Hyde's favorite word again, spectrograph, STIS, and the near infrared camera and multi object spectrometer, which goes by the nickname NICMOS. Interestingly, NICMOS only operated for 2 years because, being an infrared sensor, it had to be cooled, and the coolant ran out. It was fitted with an electric cooling device in 2003 and eventually operated to 2009. It was replaced with the Wide Field Camera 3. STIS failed in 2007 and was repaired, and it's still operating. The mission also replaced and repaired some hardware, including adding a solid state drive for data recording, replacing gyroscopes to keep Hubble stable in orbit and allow it to point at observing targets. I don't think it's possible to overstate the importance of Hubble's contributions to astronomy and our understanding of the universe. While not the first telescope, not or the last, it's undoubtedly the most well known. It's hugely versatile, partly because it can operate in ultraviolet, visible, and near infrared. Um, and has led to numerous discoveries, including fine tuning the Hubble constant, yeah, named after the same guy, which help us calculate the age of the universe. It's also made a real contribution to something important here at the AICO, public outreach. It's produced beautiful images and it's popularized astronomy. And NASA and the Space Telescope Institute have run with this. They recognize, that they've got public engagement. The images are just beautiful. I'm in my home office now, and I've got an image from Hubble on my wall because they're just gorgeous. Um, so Hubble was serviced again in 2003 and 2009. As of now, it's getting kind of creaky, but it's still operating, and its mission has been extended until the end of next year. Now, further extensions are possible as the telescope can stay in orbit until sometime between 2028 and 2040, and there's a lot of factors in that time frame. They really don't know how long it will eventually fall out of orbit, but they don't know how long, and it's not really going to have another servicing mission. But what an amazing instrument, and it's done a huge amount for, as I said, for astronomy and for making astronomy popular and kind of cool.
Absolutely. And I think this is one of the great ones as well because It's really one of the do you remember where you were when moments, because do you remember where you were when the Hubble Deep Field image first came in? Oh my gosh. And they did such a good job getting that out to absolutely everyone. And, most universities and astronomers absolutely jumped on the bandwagon to explain just how cool this was so that everyone could follow along with it. And then, of course, they had the ultra deep field, and then they branched out to all kinds of other amazing discoveries. And it's just been, it was, I mean, there's the reason why I suppose that James Webb Space Telescope is sort of like been described as next generation Hubble, even though it's kind of very different in its parameters and wavelength range. But it was also just discovery after discovery after discovery. And there is still so much that we can do with Hubble, except for maybe go visit it.
Yeah, it's amazing you mentioned the deep field image. I mean, it shows you what happens. They had a patch of the sky that seemed to have nothing in it. They pointed Hubble at it for a long, long time, and it wasn't empty. It really wasn't. And I think it shocked a few people, but amazing visuals.
Oh yeah, and the ability to point also that accurately at that smaller region of sky was something that you do have a bit of trouble with if you are here on Earth. And if you're sitting on the planet Earth, you do have a problem in the sense that your planet is in motion and turning. So anything you're looking at is going to appear to set. And on Earth, if we were to try to watch a single target for 40 hours or 60 hours or anything longer than the amount of nighttime that you have, what you have to do is you have to get multiple observatories all over the Earth to pick up the target as it comes by. And so this is how you do long time-based astronomy on Earth. But Hubble is in space, and so it has a huge advantage, as does JWST. And it's just there's so many more things we can do with it. I hope they do keep it running.
Well, I think they'll keep it as long as they can. There'd be a lot of public outcry if they don't. But interestingly, the original plan with Hubble was to have the space shuttle, when it was at end of life, go up and capture it and bring it back down and put it in the Smithsonian, which would have been kind of a dangerous thing, really, and a huge expense. But there's some talk of additional repair missions and so on to keep it going. I'm a bit cynical about that. I don't think that's in the cards, but when it finishes its mission, that's a day I'll really quite mourn.
And I can always stay hopeful and think, we do have, of course, this proposal for a lunar gateway and the Artemis missions, and maybe Hubble will be parked somewhere on the moon for safekeeping.
What a great idea.
So until then, or 2040, I suppose, if we're lucky. We'll just have to keep our eyes on the skies. And of course, Hubble being the classic example of both a telescope and a spaceship. It's just a solid win for science, for outreach, and for everything that we want to do. All right, so I think it's about time because we are nearing halfway, and the last time I forgot. So I'm going to remind everyone that you are in fact listening to York Universe. We are broadcasting live from the Allan Carswell Observatory tonight, located at York University in Toronto, Ontario, Canada. Unfortunately, the skies are really cloudy and actually spewing down hail and snow. So the telescope is closed, but we have beautiful archival images from our amazing online public viewing crew right now live on YouTube. Or if you're watching this or listening to this later on as a podcast, it'll be in the YouTube recording. For anything else about our show or details or past recordings, you can always go to yorku.ca/science/observatory. Tonight, you're listening to Paul Mackin and Dr. Elena Hyde, and we're discussing telescopes, telescopes, telescopes. So how about another telescope, actually? So I just have one more, and this is a really fun one because One of my favorite telescopes of all time is the Bok telescope in Arizona. And so I'm going to go back in time to 1960 February, and I don't actually have a date for this one, so I'm going to assume it was this week. There was a really unusual occurrence in an Australian observatory in February of 1960. And this was due to Bart Bok, who the Bok telescope is named after. Um, and this was in Australia, not in Arizona. But the very, very first computer in any observatory anywhere in Australia was installed at the Australian Observatory in February of 1960 by Bart Bok. He was one of the first to use electronic computers. That's right. You heard it here. This crazy newfangled machine runs on electricity. No analog computing. You plug it in, and he was using them for astronomical observing. And he was the first person to use them for any purpose at the Australian National University in February of 1960. He had one installed in the observatory. And I just thought this was really, really fun because, of course, the telescope itself, they had several different telescopes in Australia, and Bart Bok and Priscilla Bok are absolutely prominent in early astronomy. And they went around the world helping telescopes get set up and doing really wonderful things together in astronomy. They were at Harvard University for 30 years, almost 30 years, and they went to Australia in 1957 to 1966. And Bart Bok was the director at Mount Stromlo Observatory at the Australian National University. He was only there for 9 years, and in this time, he did amazing things for optical astronomy in Australia, including, of course, bringing in an electronic computer for the first time ever. He established a international graduate program, and the Stromlo Observatory became known as kind of Harvard in the South, and it's still one of the most prominent locations you can go to in Australia for astronomy. And he, of course, used these first electronic computers, had one installed in the observatory, and he was also, as we were talking about before, a science communicator. He was taking advantage of mass media to promote astronomy in Australia and beyond. He actually made a television series, of which you can still find some places, although I don't have a copy yet. But he made a television series that was broadcast on ABC and built tons of awareness and support for astronomy in Australia, which of course helped them to build more observatories and do some really, really wonderful things in there. And the growth of one of the largest observatories in Australia took place as part of this sort of development program. And this is how we got the Anglo-Australian telescope in Australia, or AAT. It's a 3.9 meter telescope, which is also one of my favorites. And if it's saying I'm having a lot of favorite telescopes, this is actually true. But I really love the 2DF robot they have on here. It's super fun, and now they're replacing it with Starbugs, which if you guys ever want to see some robots doing some really, really cool dances, look for the AAT Starbug dancing to Star Wars theme YouTube video. It's out there. They're these little robots that move around on the field, and they'll place optical fibers so you can observe 300, 400 different stars all at the same time. Really great stuff. And of course, I mentioned that he was a major communicator. Bart and Priscilla Bok wrote several really, really excellent galactic archaeology books and general astronomy books. And of course, after he was done in Australia, helping start the Anglo-Australian Observatory and the telescope, and setting up the first computer ever, he went back to the US and took up a role as the head of a department of astronomy at the University of Arizona, which also has some of my favorite telescopes. I know it's terrible. They're wonderful telescopes all over, you guys. And Kitt Peak National Observatory has the Bok telescope, which has on it the Bok Walk, which I am not kidding you, opens with an actual door from a submarine. Like it's literally the same exact door you've seen on 20,000 Leagues Under the Sea submarine. It's that door, and that takes you out to the Bok Walk. And that also does wonderful spectra and imaging. So when he was at Stewart Observatory at the University of Arizona, um, Bok and Bok, so both Bart and Priscilla Bok became very, very active, and they did a lot of science communication, science development, and of course, all kinds of outreach and presumably that's why he got the Bok telescope named after him eventually. He actually continued as an emeritus professor out at University of Arizona and led groups to view solar eclipses, which is a very, very popular activity for retired astronomers, I might add, including solar eclipses in 1981 and 83, and just an amazing sort of career with lots of really wonderful telescope side points. And of course, if it was this week in history, this is when the computer came in, and being able to use a computer to control your telescope is really, really handy.
Well, it's interesting because before we started this broadcast tonight, you and I were talking about, some of the roles that computers and data processing is playing in astronomy now. And it's interesting. I wasn't aware that the first use of an quote unquote electronic computer, as opposed to an analog computer, I suppose, goes back that far, and it was in Australia. That's incredible.
When it was the first one in Australia. There might
Oh,
have been
okay.
one somewhere else before. But yes, Bart and Priscilla Bok did amazing stuff in astronomy, and it's as in 1960, as now, astronomy remains one of the best places for really cutting edge computational technology. And if you want to know where Wi-Fi was invented, well, that was astronomy. Some of the most advanced computing techniques we have come from astronomy. A lot of the modern, what we call machine learning development and big data processing actually come from astronomy. And right now, data science in astronomy is necessary for a lot of our processing and our observing, because of course astronomers don't want to just view some of the stars. We want all the data from all the stars because there's so many cool things out there. And having electronic computers to help us means that, of course, we have higher accuracy, better imaging, more reproducibility, and we can make more interesting discoveries. And I have to say that, from everywhere from 1960s Australia all the way through to 2025 Allan Carswell Observatory, the computers remain a very, very important part of what we do as astronomers.
Which explains as a second year undergrad why, and I've worked this out, by the time I graduate with my undergrad degree, I will probably have taken 5 or 6 computer programming courses. So that explains a great deal to me at this point, actually.
That sounds about right. If you really want to round off, though, make sure to get a computer science class for database analysis. But I think that's still an elective at York. So,
And I
um,
believe I know who teaches that one, actually.
well, there are a few different versions, but yes. So we do have a couple reminders here as we end off our This Week in Space Astronomy history. Just for folks listening, a couple little reminders because this is February 3rd that you're running into with this broadcast going live. And if you happen to be listening to this broadcast anywhere near where it is happening, we do have a special event happening with the Allan Carswell Observatory and Downsview Park in Toronto, Ontario. On February 9th, which is very, very close to February 14th, we will be doing a special heart-shaped space event out at Downsview Park, which is only one subway stop down from York University in Toronto. And if you want to attend the event, we are doing a talk plus activities plus a live observing all out at Downsview Park, which has much, much darker skies than the university area, and we're bringing a whole bunch of small telescopes out, so it should be a whole lot of fun. If anyone wants to join, the free tickets are available on the Downsview Park website. So that's only happening on February 9th, and that is our Valentine's Day event, so just in case anyone was wondering. The other fun announcement is Astronomer in Residence 2025 with the Allan I. Carswell Observatory is happening. We're doing it again. So Astronomer in Residence has been a wonderful success with Killarney Provincial Park and the Observatory. And if folks didn't realize what that was, please go to the Observatory website and go to the blog area and look at some of the amazing pictures and stories that have been written by astronomers who've gone out as astronomer in residence, about I guess, 5 or 6 hour drive out of Toronto to the Bortle class dark sky preserve of Killarney Provincial Park. And we have 2 telescopes out there with Killarney Provincial Park, which are used all summer with our astronomer in residence. And so we actually run shows out there, and you can go to the park and listen to the shows and participate in the viewing, or you can apply to be an astronomer in residence. And that application is open now on our website. So we're doing it again this year. Yay! It's happening. And I think that's all the announcements that are fit to print.
Well, I happen to know a few people who will be applying for the Astronomer in Residence program. Not saying any names in particular, but some of them might have the initials PM, I think.
Excellent. Well, I will remind folks that positions are limited, but we do have a bit of a jury process where evaluations are done for each applicant. So if you are going to apply, make sure to get your application in reasonably soon. We will be closing applications in April, so you have a little bit of time still. They literally just opened today. So, well, on the 1st is when they were officially open. So we have all kinds of great things that have happened in this episode so far, and we've talked about our reminders, we talked about amazing telescope history. So how about some really fun telescope news? And Paul, if you don't mind, I think we'll start with your one first, because I think this one has a bunch of fun discussion items. Oh, unless I've lost my co-host. Just a moment
Sorry,
here.
no. So we've explored a bit about history, about telescopes in our history section this week, and they've come a long way since Galileo affixed 2 lenses to a tube and looked at the moon and Venus and Jupiter. In addition to developing large mirror systems and space telescopes, several other innovations have emerged, really this century, including digital imaging, adaptive optics, and segmented mirrors. Digital imaging is something we're pretty much all familiar with. We've gotten digital cameras which replace film cameras, and we all have digital cameras in our phones. Adaptive optics, it's an old idea, and it was first implemented at the Lick Observatory in California in the 1960s, this is where you take a laser, which is affixed to the telescope, and you fire it at the upper atmosphere, and that has a tendency to excite sodium molecules, and they light up, kind of orange, and form an artificial star, which you then monitor with another telescope and use the information from that monitoring to adjust your mirror, or either your primary or secondary mirror, to counteract the effects of the atmosphere on that point of light. And in some cases, this allows for almost as good quality images as those from space-based telescopes. Another significant improvement has been the mirrors themselves. You've heard mention in this podcast of the University of Arizona. Well, the University of Arizona is really quite famous in the astronomical community for its ability to cast large mirrors or mirror segments. And those can be fitted together with actuators behind them to adjust the shape of the combined mirror as part of the adaptive optics system. Of course, there's other improvements often related to optical design, and as we talked about, computers and software, which make the work of an astronomer easier and result in higher quality observations and images. One project I'd like to discuss today is the Vera C. Rubin Observatory, or as it was once called, the Large Synoptic Survey Telescope. It's located on a mountaintop in a Chilean desert. This unique instrument, and it is really quite different, is being commissioned and coming online in August of this year. The design is different from other telescopes in that it uses a three mirror system. Most telescopes kind of use a two mirror system. And because of that, even though the primary mirror is 8.4 meters in diameter, the effective size is smaller at 6.7 meters. And that really doesn't sound that much bigger than the Hale telescope, which was created in the 1950s. But it's helpful to remember that telescopes are about light gathering. So Rubin has a 75% more light gathering capability than Hale. It's also what astronomers refer to as fast, meaning that it has a very short focal length and, among other things, a very wide field of view. And Vera Rubin isn't just fast, it's incredibly fast. A fast telescope would be, an F4 telescope, maybe an F3. If you're very lucky, an F2. This is F1.25. It's incredibly fast. Rubin doesn't leverage adaptive optics, but it does have the most amazing digital camera ever built. It's a 3.2 gigapixel optical camera. Now, if you own the latest version of a standard cell phone, you're looking at a 30 to 40 megapixel camera. So the camera that they built for Vera Rubin is 100 times the capability of your phone. It's monstrous. It's actually huge. And it needs to be. You see, this camera on this enormous telescope is going to take one 15-second exposure every 20 seconds, all night, every night. It's a survey telescope meant to capture the entire sky above it every 3 days from horizon to horizon. It will capture objects that are down to 10,000 times fainter than what the Hale telescope can manage. This is key to its mission. Rubin is designed to look for things changing in the night sky, not to look at specific objects. If you have a very clear, very detailed image of the night sky down to the faintest objects, and 3 days later, a new picture of almost exactly the same place in the sky, and something changes, you should be able to see it. So the question is, what sort of things change in the night sky? And I'm not talking about the moon and the planets and satellites. Bodies move or change brightness would be obvious candidates. Bodies that move or change their brightness. Moving objects could include asteroids, Kuiper belt objects, which are kind of like asteroids in the outer solar system, comets, and believe it or not, new planets. It will also look for nova and supernova, including a special class of supernova called Type 1A. It will look for gamma rays bursts and quasar activity. More static observations include mapping our home galaxy, the Milky Way, measuring redshift, which is the rate at which the universe is expanding. Given its location and capabilities, it will complete the survey of approximately 44% of the total night sky as seen from Earth and do it 825 times over its primary mission. It's also worth noting that the amount of data gathered is stunning. Take a 3.2 gigapixel image every 20 seconds. Do that for, say, 10 hours a night. You can do a back of the envelope calculation and you'll get a big number, but the actual value is 20 terabytes per day or 60 petabytes during the 10-year primary service mission. That is getting this to say it right takes a bit of effort. 60 million billion bytes of data. It is even more remarkable that this data will be made broadly available. After processing and some review for the position, believe it or not, of spy satellites, because the U.S. government, which is involved in this, doesn't want the position of their or other satellites to be known. Um, it will be downloaded to the scientific community and made available about 80 hours after it's captured, and it will be made available to the public, as astronomy data often is, after 2 years. And this will be a real boon for the scientific community and citizen scientists. Many new, significant, exciting telescopes are coming online in the next few years. And we've already seen some real workhorses in place on the ground and in space. But I have to say, Vera Rubin is really special.
Yeah, absolutely. And we do have to give a little special shout out to the namesake of the telescope as well. Because the telescope is amazing, and I did have to look it up just out of curiosity to see if it's faster than the Vatican Advanced Technology Telescope, which was F1. So I think it's not quite faster than F1, but that's still so fast that it's going to look really, really strange if you're used to looking at sort of standard focal length telescopes.
Yeah.
Um,
Yeah, it's
and
f1.23, so they're
yeah,
both
really
really,
close,
really fast. Yeah.
really, really close. And the telescope being renamed for Vera Rubin is so appropriate because Vera Rubin was an American astronomer who worked on galaxy rotation rates, and she did so many amazing things during her career. I don't think we'd have time to even list them all in this particular episode, but she was one of the ones who looked at galactic rotation curves and finding the discrepancy between the predicted and observed angular motion of galaxies, which is one of the reasons why we know about the mysterious thing called dark matter. And she's still, a lot of her work is still foundational to dark matter studies today. And of course, in her lifetime, she was born in 1928, and they didn't exactly have an easy go for women who wanted to do an astronomy career at that time. And there's some wonderful quotes from her, and I believe there's at least two different biographies that have of course been written about her and her long and illustrious career, because she was born in 1928, and she did pass away back in 2016. But she not only of course developed this study of galactic centers, looking at the rotation curve, figuring out that something must have been helping the rotation along in galaxies, so to speak. And this was what led Fritz Zwicky to suggest an unseen component, which coined the phrase dark matter, and really revolutionizing astronomy in the middle part of the 20th century. But she has been quoted as saying that from a small age she was really enamored with astronomy, and would, and I quote, prefer to stay up and watch the stars and go to sleep, which I thought would be a wonderful quote for probably everyone involved in this episode today, because I think we've all been guilty of that at one point or another, of watching the stars instead of going to sleep. And she had a very, very, very long and illustrious career, with lots and lots of different, I suppose, victories along the way. But there is one other particular thing for her that I thought I would sort of bring into the episode as kind of a maybe a keystone. She completed her master's thesis after lots of various different other studies, and she investigated whether groups of galaxies moved like other objects in the universe. So, for example, like objects in the solar system orbiting the sun? Do galaxies move like that? And so she investigated movements that actually led to the discovery of the supergalactic plane in out there in the cosmos. And she presented the results at the 1950 American Astronomical Society meeting. And after completing her thesis, she was called in by her thesis advisor, who offered to present her findings under his name. And at this time, she was actually pregnant and not even a member of the AAS. And but she's like, nope, nope, I can go. I'll get there. And she actually had no car, and this is according to her biography. She was like, no, 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 you don't need to present my findings under your name. I'll be there. And the actual quote is, no, I can go, but she had no car. So while she was pregnant, her parents drove her from Washington, D.C. to Ithaca, crossing the snowy New York hills with her parents and the first grandchild, and um, her being pregnant. You know, she was 22 at the time, and she made it. She got there. She presented her results and gave birth to her next child 3 weeks later. So quite the adventurous astronomer, and really an amazing character from Astronomy All In. Um, Completing her degree, and she did go on to really help quite a lot of people get into astronomy that would not maybe have otherwise had as good of a chance. So very inspirational person, and absolutely significant work in this area. So it's really, I think it is really, really appropriate that this amazingly capable scientific telescope has her name on it.
Yeah, and that's a great story. And you know, this is a lamentable bit of history that the role of many women in science has been supplanted due to sexism and chauvinism of the day. But yeah, she's a bit of a hero, more than a bit. And this telescope is absolutely aptly named. It's just such an exciting uh, uh, tool to have come online. And I believe, I'm not totally certain about this, she lived to know that the telescope was going to be named after her, and which makes me very happy.
I hope that's true. I didn't read that part in the biography, but that would be nice.
Yeah.
You know, of course, as you say, the telescope itself is really exciting for lots and lots of reasons, not just for galactic archaeology, which it's going to be excellent at, but it's going to be able to do an incredible amount of crossover science for all kinds of things. And even just in our own local solar system, we're still finding so many objects, especially smaller objects, and a 3.2 gigapixel image every 20 seconds. This is going to bring optical astronomy over to where radio astronomy already is, and we are going to have the big data problems to deal with. So get your data pipelines ready, everyone, because this is going to be quite the treasure trove.
A great problem to have.
Absolutely. I am absolutely looking forward to it. And if anyone knows somebody who wants us to travel over there to see the opening, we're happy to go and report on the telescope. All right, everybody. With that exciting news and this a very, very exciting telescope, I will just end off the show with one final extra little note. If you would like to learn about how to apply for time at a telescope, in particular the Allan I. Carswell Observatory, I will actually be giving a talk on how to apply for time with our beautiful 1 meter and 60 centimeter telescopes, which anyone can do, including RASC Toronto Centre members, members of the public, members of the scientific community. And that talk will be at the RASC Toronto Centre RAN meeting on YouTube. Live on 5th of February. So that's February 5th, 2025 from 7:30 p.m. on the RASC Toronto Centre YouTube channel. And with that, I will call it for a close this evening and say it has been a wonderful show and very, very fun being here. I hope you all have had as much fun as we have talking about telescopes. They are all kind of my favorites. But everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Paul Mackin and myself, Dr. Elena Hyde. And you can always connect with us on Facebook, Instagram, or PixelFed, and check out our website for show notes, content updates, and of course, contact info over at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, and have a good night, everyone.
Good night, everyone. Stay warm.